Right, in this video we're going to look at using tree diagrams with a little bit of conditional probability. So the probability that I wake up late is 0.2. If I wake up late, the probability of arriving late to school is 0.7. And if I wake up on time, the probability that I'm not late is 0.9. What is the probability that I wake up late and I'm on time to school? And B, what is the probability I'm late to school? And C, I am late to school, what is the probability that I woke up on time? So let W be waking up on time and L arriving late to school. So the first thing we're interested in is whether I wake up on time. So drawing the tree diagram, first thing I'm interested in whether I wake up on time or that I do not wake up on time. Then I can either be late or not late, late and not late. Right, the probability that I wake up late is 0.2, therefore the probability that I wake up late is 0.2, therefore the probability I wake up on time is 0.8. If I wake up late, the probability of arriving late to school is 0.7, so this one here will be 0.7, this would have to be 0.3, and if I wake up on time, the probability I'm not late is 0.9. So this one here is 0.9, and this one here would be 0.1. Now to get the probabilities of waking up time and being late, which is W intersection L, you multiply across the arms, mainly because you multiply because of the rule of conditional probability. The probability of waking up on time and not arriving late is going to be 0.8 times 0.9, which is 0.72. The probability of not waking up time and arriving late is going to be 0.7 times 0.2 times 0.7, which is 0.14. And the probability of not waking up late, of waking up late and not arriving late to school is going to be 0.2 times 0.3, which is 0.06. Now, what we've got to remember is that all these probabilities here add up to 1, so that's a little check, and that these events here are mutually exclusive, i.e. if this one happens, the other 3 will be excluded. Right, I'm drawing out the diagram again. Right, so A, the probability of waking up late and I am on time to school is going to be the probability of waking up late and not being late to school, which is that one, so it's going to be equal to 0.06. So you should try to annotate your diagram if necessary. And the probability of being late to school, well, I'll be late to school here and here. All right, so they're mutually exclusive events, so I will need to add those together. So it's going to be 0.08 plus 0.14, which is 0.22. Right, just quickly drawing out the diagram again. Part C, the probability I wake up on time, given that I was late to school, is going to be the probability, we're going to use the conditional probability, so the probability A given B is the probability of A and B, intersection B divided by the probability of B. So we're going to want the probability of W given L, which is going to be the probability of W and L divided by the probability of arriving late. Well, the probability of W and L is going to be this one here, which is 0.08. So this is waking up time and being late. Divided by the probability of being late, that's going to be those two there added together, which we worked out in the previous part to be 0.22 from part B. That's going to give me 8 out of 22, which is 4 out of 11. So this has been a video to show you how to do conditional probability using tree diagrams and how to write down a tree diagram. I hope you've understood, and I thank you very much for watching.